Thank you for that introduction. So, good day everyone. I am Raji Garcia, one of the technical support engineers of Midas IT Philippines. In this presentation, I will discuss Midas Gen with its latest major update, the version 3.1 with NSCP 2015. And this presentation is entitled NSCP 2015 in Midas Gen. And this will be the content of our today's webinar. First, I'll just introduce who is Midas IT Philippines, what are the services they are offering right now. Then, we'll proceed immediately to our main topic, the update version 3.1 2021 in Midas Gen. Here, we will focus on the incorporation of NSCP 2015 code in the software. We will start with NSCP 2015 provision of RC design, then followed by the load combination, and the PNS 49. Okay. So Midas IT is an engineering software development company based in South Korea. It offers a wide range of services for bridges, buildings, geotechnical, and mechanical engineering. In 2016, Midas IT Philippines is established, and now I am proud to tell you that we now have the #1 market shares in engineering software solutions worldwide. So this is Midas Gen, your one-stop solution to model, analyze, and design any types of vertical and general structures. It gives us various choices of modeling, different comprehensive methods of viewing result, vast database of material and design codes, and unparalleled technical support. Before, whenever we design RC structures, we use the ACI 318 as our design code since that's the reference of our NSCP code. So, as mentioned, NSCP 2015, our local code has been included in this year's major update in Midas Gen. This has been possible through the valuable request of our clients to make Midas Gen more particular for Filipino engineers. Let's start with the concrete design. So, this is Midas Gen. After modeling and performing the structural analysis, now we can finally choose NSCP 2015 in the vast database of the design codes for reinforced concrete. These are some of the checking that we can choose to apply in our models to be able to design them in accordance with NSCP provision. We have the option to check the beam deflection. We also have the option to consider the special provisions for seismic design and to select which frame type we could use. It could be a special moment frame, intermediate moment frame, and ordinary moment frame. These options have their own design calculations according to the code. And later, I will show you the program interface of this and their reference in NSCP 2015. Let us start with the capability of the program to calculate the deflection limits. On the left side of your screen is the deflection control found in the Serviceability Parameters in Midas Gen. And on the right is the reference from NSCP for these limits. This can be found on table 424.2.2 of NSCP 2015. So, L1 over 180 for the immediate deflection of flat roof due to live load and rain loads pending is excluded. L over 360 for immediate deflection of floors due to live load. L over 480 and L over 240 for roof or floor supporting non-structural elements that are likely and not likely to be damaged by large deflection, respectively. And for the designer's preference, since it is stated on the code that these limits shall be permitted to be exceeded if measures are taken to prevent damages to supported attached elements. We have the user's input for this. Next, if the special provisions for seismic design option is not checked, The program will proceed to design as general BLEM as follows. First, it will calculate all the row limits, the minimum, the maximum, and the required. Then, after computing for the row to be used, it will then calculate the rebar quantity and spacing according to the rebar size that you choose. Then, finally, check if the demand exceeds the moment capacity. However, more checking is required if you choose for special provisions for seismic design. For example, the limiting section size for your structural elements for beams in accordance with NSCP 2015-418.6.2, the clear span should be more than 4 times the effective depth. The width of the beam shall be more than or equal to the 0.3 of the height and should not be less than 200 millimeters. If this limit exceeded, the program will skip the design and will show messages such as this. For the column, the checking also include the minimum section sizes according to NSCP 2015-418.7.2.1a. The shortest cross-sectional dimension should be 250 millimeters, and the ratio of the shortest cross-section dimension to the perpendicular dimension should be less than or equal to 0.4. Again, if these limits are not satisfied, these messages will appear on the message window or to remind us that we need to adjust the section sizes to be able to comply with these provisions. And on the left are the snapshots of the actual interface of the program showing us the detailed calculation with the reference in the code. So for the shear, here is the sample computing for the VC reference at NSCP 215-418.6. Next, the beam stirrup spacing also from NSCP 2015-418.6, and also we have here a snip of the calculation for the column lateral ties or hoop spacing. All in accordance with NSCP 2015 as shown on the right side of our screen. And for additional provision, we can find the consideration of ductile design in accordance with NSCP 2015 in Midas Gen. So the option is here. Under NSCP 2015 RC design, RC strong column weak beam, and ductile design. And after performing the RC design, these are the results that can be viewed in our program. We can have them in tabular format as shown in this picture, in graphical format with the sectional drawing, placement of bars, PM curve for the columns, and the summarized calculation report. And we can also view and print the detailed report, which include the detailed computation with the reference from the code NSCP 2015 as shown earlier. And that's for the RC design of Midas Gen using NSCP 2015. Included also in this update is the additional of the load combination that are found in NSCP 2015. Along with other international codes, we can now find our local code in the options of our auto-generation of load combination in Midas Gen. In this table is where you can find the reference of Midas Gen in adding NSCP 2015 load combinations. For the strength combination, we can find it on section 203.3.1 ASD or the service combinations at 203.4.1, alternate combinations at 203.4.2, and the special load combinations for seismic at 203.5. Per code, we have the option to reduce the floor live loads to 0.5 for the live loads other than those with values exceed with 4.8. kilopascal. We can add the redundancy factor as per 208-20 and even the amplification factor for seismic. And this is the interface of Midas Gen with the said combination. We can consider lateral soil pressure factor and the orthogonal effect, add a special load combination for seismic, and other reduction factors for live load as stated in the code I presented earlier. And we can auto-generate an NSCP 2015 load combination not just for concrete design but for steel and footings as well. And that's for the load combination in Midas Gen. And finally, we have also the PNS49 in the database of Midas Gen in reinforcement bars used in concrete design. You can see it here along with the other international codes. We included the rebar strength, which are the tensile and the yield strength of the rebar as per the code, and also the sizes or the diameter of the rebar that are standard here in the Philippines according to PNS 49. So now, let's check it in actual using Midas Gen. Let's open our software. So here is a sample model. As you can see, the modeling part is already finished. What I did here is just to change some of the sectional properties. Like this column, I changed the column size C2 to 240 by 400 and the girder to 190 by 450. And then after changing it, I assign it to the model. So let's verify it. So under the section, I'll just double click the C2. So as you can see, these are the column C2. And for the other members, let's check for C1. So these are all the C column 1 and the G1 for the girder 1. So as you can see in the model, and the G2, which has a size of 190 by 450. So all girders on the right side. And the G3, all the vertical girders. B1 and C3, all the front columns, and G4 at the center. Okay. Also, in this model, the loads are already defined and assigned. So if you want to verify it, we can see it here under the static loads. We can just right click the floor loads and then display. So here, okay, and then let's undisplay it. So as a standard procedure, after modeling and defining the loads, we run the analysis, and then after running the analysis, we can now proceed with the design. So after running the analysis, we can now view the result of the analysis here on this tab. We can show different types of result. We can show the reaction, the stresses. So any types or any kinds of results we want to view, we can view it here. So first, let's define the load combination. Click the load combination here, and then under the concrete design, we can choose to manually input the load combinations, or we can choose the option auto generation. So click auto generation, and then as you can see here, we can now see the NSCP 2015 as one of the design code in the auto generation of load combination. So let's select NSCP 2015, and at the bottom we have also the option we have also included, or we have added the option to consider redundancy factor. We can just check it here and then apply the factor here, load factor here. So for now, we don't have that, and Also included in this update is the additional or the option to consider live load reduction factor or DF1 stated in our code. So for example, if we choose to consider the live load reduction factor, just check this box and then click this factor for live load reduction and then select. If we separate the live load for those with 4.8 kPa, and for those live load it doesn't reach 4.8, so that we can choose which live load we will apply the live load reduction factor. So for example, I will choose this live load, so just click add and then click OK. And then we have also the option here to consider the orthogonal effect. Just check this box and then create a load case. For example, this EX, and if we have a response spectrum, we can also add it and then click OK. And then we have also the option here to generate additional load combinations for vertical seismic factor and special seismic load. So after defining the load combination, we can now click OK. So these are the load combinations generated. So we can verify it here. We can click the spreadsheet form. So as you can see, we have applied the live load reduction to all live load a while ago. So you can see the 0.5 here. And the 100 and the 30 for orthogonal effect, we can see it here also. And we can modify it by just clicking or double clicking and then changing the values. So okay, after defining the load combination, we can now close this tab. And then we can now proceed with the design. Go to design tab, and then here we can now choose NSCP 2015. Just select NSCP 2015, or under the RC drop down, RC design, and select design code. So we have here the NSCP 2015 under the design code. So let's select NSCP 2015. For this model, we will choose to apply special provisions for seismic design. So we will check this one, and then we will select the special moment frame, so that the software will consider checking the limiting section size under the chapter 418 of NSCP 2015. So let's click OK. And then after defining the design code, we can now define the concrete material as usually. So here I have already defined the concrete material. So I separate the concrete material for column and girder. I only use 5,000 PSI for column and 4,500 for girders or beams. So, and then for example, I will modify this material. So click item, and at the bottom we can modify the rebar selection here. Under the code, we can choose the PNS 49, and then for the grade of main rebar, we can choose the 420R. And then we can choose the 420R, and for the sub rebar, we can choose the 280R. On the right side, we can see the FY, or the yield strength of this reinforcement here, and then click modify. And also for the beams material, we can modify it also. After modifying, we can now close this tab. We can also modify some of the provisions under this code. So let's check the limiting max or limiting minimum section sizes. As you can see here, the design code is to NSCP 2015. We have the option to consider minimum section size limit. So if these items are checked, it means that the software will check the provision as per code. So if we have a section less than the minimum size, the software will notify us. But if we choose to uncheck these items, the software will bypass the code. Okay, so for now, we will check check so that the software will consider the minimum sizes. And then also here we have the serviceability parameters. We can modify it here. Just select the deflection control, or we have the option here to use the user define and then apply it to the particular member, or we can apply it to all members. And also we can modify the design criteria for rebar. Just click this one, and then as you can see in the rebar code is already in PNS 49. So these are the actual sizes based on the provisions of PNS 49. So just select what rebars are we going to use. We can choose multiple or we can only choose one. So for now, we will only choose one. So let's say the diameter 20 for beams, then click OK. And then for column, likewise, we will just select D20. And for braces and shear walls, if we have those structural element, we can modify also the parameters here. So click OK. So after defining the design parameters, we can now perform the design. Just click this perform batch design, and then first let's design the beams. So check the concrete beam design and then run. So this is already the design result. So as you can see, the only beams that are being designed was G1, G3, B1, and G4. And as we can see, G2 is not designed because, as mentioned earlier, G2 is below the minimum size as per code. As you can see, it says here that the size is 190 by 450. So we can verify it here. So go to close this tab and then go to analysis message. So here we can verify it here. It says here that skip member number 1 has an acceptable section size. BC is less than 200 mm. So that's the reason why G2 is not designed. Now let's try to design the column. So click again the perform batch design and then click concrete column design. So as you can see, while running the design, we can view some of the comments or reports under the message window. So as you can see here, it says skip beams linked with members number 5 to 6 must be designed first. So let's check it later after the design process is finished. So here, as you can see, there is only one column that is being designed, the C1, even though we have C1, C2, and C3. So let's verify why. Just close this tab and then go to the message window and click the analysis message tab. So here are some of the errors. Some columns are not designed because some beams that are linked to it are not yet designed. So we must first design the beams. So I think these are the G2 since it is not being designed a while ago. The column linked to it is not designed also. So some of the errors says here that member number 95 has an acceptable section size. So as per our NSCP code, the minimum size is 250 mm for columns. So that's for the design result. So also we can verify some of the detailed report. Again, for example, for column, let's try again to run the design for column. And then, example, for C1, click member. And then, for example, this member, check this one and then click the detailed. So here is the sample detailed result or the detailed design result. One good thing here is that it's very transparent. Even the formula used during the design process, we can verify it here. And one good thing here is that we can cross-reference it to our spreadsheets, and then we can check if the computation is correct or wrong. So at the bottom, we can see the shear design or the calculation of the beam column joint capacity about the minor axis. And here we can see the calculate data of special provisions for seismic design, the RC column design, you can see it here, and at the bottom we can see the shear capacity of biaxial loaded RC column. So that's the detailed result of our RC design. And then we have also the option to just select the graphic result or the summarized report. So just click this one, graphic. So here is the sample graphical design result or the summarized report. We can see the graphical representation here, the design condition or the material inputs, and then we can only see here the design capacity ratio since it's already in summarized form, and then some of the forces or the designing forces, and also included the PM curve. So I think that's all for our NSCP 2015 in Midas Gen. For inquiries, you can contact us through our email at phinquiry@midasit.com or philippines@midasit.com, or you can call 0995-986-1467 for more details. So thank you for watching. Hope to see you again on our next webinar.